Okay, so now we know what conditions to check. That was quite the process. We know how to get our p-value, which is also quite the process. So now we put it all together. We're going to try 2 problems from start to finish. So the first one has to do with the Festival of Trees. The mean height of Christmas trees at the Festival of Trees is supposed to be 6.2 feet. The organizers are worried the trees are getting too tall. Tall trees become top heavy, tip over, and become dangerous to spectators. Therefore, the organizers are going to test if the mean value is greater than 6.2 feet. A random sample of 36 of the total 700 trees has a mean of 6.8 and a standard deviation of 1.8. Create a hypothesis test, use significance level 5%. Is there really that many trees at the Festival of Trees? Have you guys ever gone? That seems like a lot of trees. I'm going to have to look into that. Okay, so we want to perform. Notice that we're doing that same state, plan, do, conclude situation from the proportions. So we want to perform a significance test using or at a significance test at alpha is 5% using the hypotheses HO. All of our problems today are mu. The trees are supposed to equal 6.2, or their max is 6.2. The alternative is that they're getting too tall. So it's really greater than 6.2. Notice those numbers are the same, 6.2. Where mu is the actual mean height of the Christmas trees at the festival. So we have our test stated. What's our plan? A 1 sample t-test for mu. A 1 sample t-test for mu. Okay, we check our conditions. So looks like the first one they want us to look at is random sample. So a random sample of 36 trees was taken. Next one looks like 10%. So this time they actually told us population size. What is our population size? 700, very good. So 36 is less than 1/10 of n. 1/10 of n would be 70. 1/10 of n is 70. So we're definitely less than 70. And then last, we get lucky because large counts is met. N is 36, which is greater than or equal to 30. So the CLT applies and we can use T procedures. So this one we get lucky. So our do then is to calculate our test statistic and find our p-value. So our degrees of freedom is n minus 1, which is 35, but just like on the last one, we use 30. Then I calculate my t. So I'm going to write out the calculation, but then use my calculator to actually find it. So it's our sample mean, which was 6.8, subtract our null, which is 6.2, divided by the standard deviation of 1.8 over root 36. Then I'm going to do stat test 2 and adjust my numbers. So mu was 6.2, sample 6.8, 1.8, 36, and remember to change it to the right direction, so we're doing a greater than. So this is the same t-value as last time. Last time it was -2 and +2. This time it's just +2. So if I use the table, so from table, p-value is, well, this is the same as our last problem. We found in our last problem that the table for t is 2 would give us 2.5% to 5%. So that's what I'm going to put here. The table gives us an estimate that our p-value is between 2.5 to 5%. From your calculator, the p-value is 0.20267. 0.0267. So that does fall within the range that our table gives us. So based off of our calculator value, that's what I'm going to use. If you were going to use the range, you would say since the p-value is between 2.5 and 5%, and then finish. But we're going to use the exact value. So since the p-value, 0.0267, is less than alpha of 5%, we fail. Just kidding. We reject. When the p-value is low, reject the hoe. We reject HO. There is convincing evidence that the actual mean height of the Christmas trees is greater than 6.2 feet. And this I take from our alternative. So I'm going to highlight those so that they match, just so that I have it for my reference. So I have convincing evidence that the alternative is what's true. The other thing that I want to highlight is that if you give the value from your calculator, you have to specifically state on the problem that it's from your calculator. Even though they know the only way you can get that is from your calculator, you still got to say from your calculator. I don't know why. Okay, so that's an easier one. Now, we got to do the big mama. So, I would know just looking at this problem that it was going to be a little bit more involved because they give us the sample data. And whenever they give us the sample data, that usually tells me I'm going to have to do a little bit more work. So, Utah ZHT 97.1 radio station claims to play an average of 50 minutes of music every hour of the morning. So, the claim is they play 50 minutes of music per hour. I would suspect that the morning would be 6 a.m. to 10 a.m. I think it depends on the radio station, but I think that that's pretty accurate. So they claim 50 minutes of music. However, it seems that every time you turn to this station, there's a commercial playing or someone is talking. To investigate the station's claim, you randomly select 12 different hours in the morning. And then we make kind of a sad face because we can't use CLT. 12's too small. I'm looking for my highlighter. I just used it, family. Found it. Found it right in front of me. Sample size is small. So over the course of a month, you randomly select 12 different hours and observe or write down how many minutes of music was actually played. They want us to test at our lowest level that we've seen so far, which is 1%. That's very low. So we want to perform a significance test at alpha is 1%. Using the hypotheses, HO is that mu is the claimed 50 minutes. HA is that they play less than that. Because every time you turn it on, they're talking or there's a commercial. So that means there's less than 50 minutes of music. Where mu is the mean minutes of music played every hour of the morning on this radio station. So that's very specific. I would imagine that they would give you full credit for mean minutes of music played every hour of the morning. Maybe even mean minutes of music played every hour. But the more specific you can be, the better. Okay, that was our state. We had to state what we were doing. Now we got to give our plan. We want to do a one sample t-test for mu. And in order to do that one sample t-test, we have to check our conditions. Okay, condition 1 is randomness. So n equals 12 different hours was randomly selected. Or you could just say n was randomly selected, or the hours were randomly selected. You have a little bit of freedom. Okay, n in this case is all morning hours. So we'll be conservative and we'll say that we're looking at a 30-day month. And if we have 4 hours of morning time, that means we have about 120 hours in the month of morning time. So it is reasonable to assume that 12 is less than or equal to 1/10 n. If morning time really is just 4 hours, and we choose a month that has at least 30 days, this is exactly 10%. You don't have to calculate that. I'm just letting you know. And now comes the work. So we are not told that this population is normal, which means this is the point at which we should enter the data in our calculator. So to do that, we're going to go to Stat. We're going to hit 1. And you're going to enter that data into one of your lists. Remember, hit clear, not delete. Hit clear, not delete. Give you about 30-ish more seconds. Once we have it entered, we're going to pull the one variable stats. So we're going to hit Stat. We're going to arrow over to Calc, and we're going to choose option 1. Make sure that your list is correct. And then we're going to pull quite a bit of information from this. So number 1, I'm going to pull my sample mean. So next to this due, I'm going to write down my sample mean was 49. My sample standard deviation was 165. And I can just do my degrees of freedom here right now if I want to. I also know that I'm going to make a box plot for this data, so I'm going to pull those values really quick so that I don't have to jump back here. So my min is 46, and I'm just writing it over here to the side. I'm not even labeling them. I'm just quickly writing it down. Q1 is 48, median 49, Q3 is 50, max is 52. Now the reason that I personally don't automatically put those in the box plot, because I want to verify that there's no outliers. Because if I graph that and then there's outliers, I got to erase things and fix it. So I'm going to go to blue button, Y equals. I have one plot on, so I'm just going to select that plot. And I'm going to choose the box plot that looks like it has outliers, so the bottom left. I'm going to make sure my list is right, and then I'm going to hit graph. Now, I don't see anything, so you have to hit zoom. It's the middle graphing button, zoom, zoom stat, which is 9. And now I can see a very nice symmetric box plot, no outliers. So I will proceed with graphing that. I draw my X hours, or my X axis. I'm going to start at 45, and I'm going to go to, I don't know, maybe 53. So I'm starting one below and ending one above my max and min. There's many reasons to love a box plot, but one of them is that this is easy to label. So this is the minutes of music. My min was 46, so I just go through and place my 5 dots. Q1, 48. Median, 49. Q3 is 50. Max is 52. Then I connect my straight lines, do my box. And this is a perfect box plot in that it is symmetric. It's not approximately symmetric, it is symmetric with no outliers. So that box plot came out very nicely. Now the other thing that they say that you can consider, and I would at least check it if you feel comfortable getting this graph, is the NPP. What I don't feel comfortable with is the graphing. And that's because I'm unclear, we don't really cover it in this class, what exactly we're graphing on the y-axis and the x-axis. So I worry that we would get marked off for not labeling right, but I can use it just to verify that I should be able to use T procedures. So if I wanted to do that, I'm going to go back into my graph, and your NPP is this very last graph. Your NPP is the very last, the bottom right. I hit graph, and I have to zoom stat again. So zoom, option 9. And then I get this very lovely linear NPP. So I can for sure use a T procedure. And if I wanted to, I would sketch this basically roughly as I see it on my graph. It's not perfect, but it looks similar to what's in my calculator. This definitely has a linear form. It's not even questionable. Those lines are, these points I mean, are definitely going in a straight line, a positive line. So based off of those two things, it is reasonable to assume that the population is normal. And the reason that we even care about that in the first place is so we can use T procedures. So this last blank is N is 12, which is less than 30, but the box plot and the NPP show that it is reasonable to assume the population distribution is normal. Now, the only reason that I can frame this condition like I did is because I wrote very clearly on my graphs that this is symmetric with no outliers and has a linear form. So if you don't do these two things, you have to say in the response, n equals 12 is less than 30, but the box plot is symmetric with no outliers, so it's reasonable to assume blah, blah, blah. Does that make sense what I'm saying? You cannot just graph it and then say, based on the graphs, blah, blah, blah. They want to know, well, what about the graphs tells you that? Okay, we're finally at the last part. This is still better than the 5-paragraph essay. I'm just saying. Just saying. Okay, so we got to find our t. We have all of our information already because we pulled it from our calc. So sample mean was 49. Sample, just kidding. The mean from the null was 50. We divide that by standard deviation of 1.65 over root 12. And then just like last time, I'm going to get this value from my calculator. So I'm going to hit stat, test, option 2, but this time I'm going to choose data because I actually have the data. You can do stats if you prefer, that's still an option, but this is the first one that I can actually do data, so I'm going to try that. So I hit data, my null value is 50, and the list that I put that data in was list 3. My test is less than. It's a one-sided less than. And then I'll draw, but you can hit draw or calculate. That shows me my t curve. I have a t of negative 20976. And I'm just going to write the whole thing because it doesn't really bother me to write out the whole thing. And then I'm going to say from calc, p-value equals 0.0299. But then I'm also going to practice finding it from the table really quick. So from table, I'm going to go to degrees of freedom 11. So that's just below a gray section. I'm going to slide right until I'm in between two numbers. So 2.09 or 2.1. So this time I'm between these two numbers. On degrees of freedom 11, a t-value of negative 2.0976 is between these two numbers. So if I slide up, that tells me that my range my table gives me is 2.5% to 5%. So 0.2525. And it is, our p-value that we got is between those numbers. So our last step then is to conclude. And I always use my calculator value. So since the p-value, 0.299, you can round up to 3 also if you'd like, is greater than our very small alpha of 1%. We used a very, very high significance level this time. Or maybe you would say, no, I think you would say high. So we, p-value is low, we reject, so we fail to reject HO. Our p-value is not low this time. Even though it's only 3%, that's still greater than our significance level of 1%. We do not have convincing evidence that the actual mean minutes of music played every hour of the morning on this radio station is, and then we use the alternative, less than 50 minutes. So whatever we conclude, we tie that to our alternative. Not bad. It is a lot of work, but then by the time that we're done, I feel really proud of all the things we did. And this is the reason why the last 3 units are so important for your test, because this one problem tests you on like 3 different chapters worth of knowledge. You need to know sampling distributions to do this. You need to know testing to do this, and you need to know how to graph to do this problem. So they love to ask you these problems in the free response because there's so many different things that you need to know in order to solve it. So for your check for understanding, this attitudes problem is this part where we checked just the conditions. Then it goes down and has you find the test statistic. So that's what we did. Where did we do that? I've lost my page. Here at the bottom of this page. So the first question's at the bottom of our first page. You do it the same. Second question is this kind of a question. Then your third is a multiple choice where it asks you to give the range of the p-value. And then your very last problem is to do one more like we just did with the data set. This data is going to be skewed, but there's no outliers, so do the test anyway, even though it is skewed. You feel okay? Okay. Okay. Give it a try.